Alright, I'm Michael Giardino, and this is Brandon Samuels, and we're working on Dr. Demetrius is our advisor, and we're working on traffic monitoring using video sequences, and it's actually a two-part project. My focus is identification of possible vehicles using a webcam, like using regular 640 by 480 images, and then Brandon's working on the actual tracking and the predictive tracking. So the first step is for identification of vehicles is you have to create a background image, and then you subtract your background image from the current frame. We did this in some of the presentations in the first semester. Then there's thresholding and enhancement, edge detection, and the identification and centers of each object. So to create the background image, you take a sequence of frames, X and Y representing the pixel images, and then T being a frame at time T. And you take a pixel-wise median of a sequence. Right now we're doing of 10 frames, not consecutive frames, because at 15 frames per second the objects may not move enough. I'll show you. But if the objects don't move enough, then the median may contain things like a stop sign or people that are walking slow. So you take a median. Here it is mathematically. You take a median of, like I said, consecutive frames with a certain. Right now the time shift is 3 frames, which gives about a minute. No, 3 seconds of time to compute the median. And there are other ways. Okay, here's we had a little trouble getting actual video. This is. And as you can see, you have a little person here. You have some cars up here. This is recorded from the 6th floor, and then later on, there's a car here. These cars have moved, and so there we go. Okay, and this I'm sorry, and then this is the ground image. As you can see, there's a problem. You see that this car here apparently pulled over on the side, so it ends up in the ground image. And this guy looks like part of the tree, but he ends up in the ground image.
Swamp monster.
But we in previous work, this is one of the papers I had to read. What they do is they update the ground image periodically. They put a weighted. This is the alpha here. Is a weight given to new images, so they average each new frames in with the old image to to change lighting conditions and that kind of thing. But our proposed modification that we're working on now is to do a median, like to redo the median and add that in weighted. So because when you add in, there's a problem with just using the median and adding a single frame in, because then you get. If it's 1/10, if the weight is 1/10, for example, you can still get dark objects that show up in the ground image that'll modify the ground image. You can see that in some later pictures. So that's one change from the research that we've been doing. This is just mathematically the difference between, you take the absolute value of the difference between the frames, the ground frame. So this is just the plane difference. You can see the cars, and there's the little guy, and the car with the shadow, and possibly noise. It's kind of hard to see. Then we do some blurring in order to get. Let's see. You can't really see in this bright light, but there's a lot of pixelation from the compression of the video. So you have these you have little squares in here that could show up as false positives. So as of now, we're blurring. You can see it blur a little bit, and then we threshold the image. This can be changed, so this will give a binary image of possible candidates. You can see they still have little small spots in here, which is noise. So then we dilate and then erode it to try to get rid of, with different settings, you can get rid of possible false positives. And then edge detection, just use a simple horizontal and vertical edge detection to find the coordinates of each object, and then from these edges you can these are the objects, and then you can find the centers just by taking a mean from each object. And this is it put back on the video, And as you can see, oops, we don't have video. You can't really see these, but it plots the centers of each of these vehicles. So as you lose it behind the tree, and it creates, when the trees move, you get possible false positives. But it was hard. You have to do each one of these frames individually since we didn't have video. We have like 1.5 gigs of video, so it wouldn't work. But that's what I've gotten so far. Right now I'm working on creating a mask to test probability, so that you don't have to check areas like the building is right here. So there's no need to check that for new, or if there's a change over here, you can probably completely ignore it. Dr. Demetrius suggested that instead of just doing a binary masking, to do some kind of probability gradient, so the more popular areas get more, and that way Brandon can use that for his prediction. And this is, and Brandon will talk to you about the tracking.
Okay, so next we have a series of slides that will show how I intend to track my initial tracking of objects. Okay, so this first image here is the basic it shows the basic algorithm. First, I locate this square here is what is the mass that I'm going to be looking for in this next series here. I locate it on the first image. Basically, this is what I plan on getting from him, a location, an initial location. Okay, and it locates it. Okay, next, then it searches an area around where it was. It doesn't search the whole, so, and this here is that red box here. So it searches just this area here, and basically from that we locate where it is, and then shift, and then search an area around that, and continue as it goes along. So as you can see here, it will pretty much follow as it goes along. And also here shows we have I implemented a variable window size here, so once it goes to the edge, it doesn't check outside the actual image, and then we just shrink down the window size here and just search less. Okay, and as it follows it, and then as you see, the window size gets back to its normal size as it goes to the center of the image, and as it follows it along. Okay, now when combining this with his location, we initially we were very successful initially when we first located. We were successful following it initially until you're gonna see it runs into some interference. Okay, so first we tried. We're not supposed to be tracking vehicles, but we're supposed to be tracking vehicles, but we kind of got this human here walking on the sidewalk, and as you can see, so as you can see, as the human moves, it kind of goes with it. And here is the mask here at the bottom. This mask here is the human that we're looking for. This is taken from the previous image. This mask here, so it's taken from the previous image, and then we're going to search for this on the next image here. So as you see it, this image, the human here is pretty much predominant of the mask initially. So we initially we follow it, and as you see, once the human becomes behind the tree here, the tree in the background becomes more predominant. So we kind of just stay on the tree, and the human just keeps walking up. And here, as you see here, the human is completely gone, but we're still stuck at the tree. So that is something we're trying to work on. Okay, and this is just basically off a grayscale image here. Next we have here, we're tracking a vehicle. We basically subtracted the background, and we're using same idea. We get an initial finding from his algorithm, and he gives us a mask or something like that. Then we search for it. Okay, as you can see here, go back. This actually is the same thing, so it's going to actually find that, and it stays the same here. So we take this mask here from what we found here, and we look for it on this one here. And pretty much this is the closest representation. So as we go on, you'll see that the mask actually changes. Okay, so from we're looking for this on here, we find this thing here, and then that's our new mask now. Okay. And as it goes on again here, with this here, we also lose the car, and we start to just pick up some noise here, and then now, as you can see, where it locates completely like at the edge, and it's pretty much out of just picking random things now, since we pretty much lost it. This problem here, we plan on figuring implementing some type of common filter to as you know, cars move with a certain velocity. You know, you kind of want to we can use some type of prediction instead of just actually tracking it. We can predict and look in a specific area, which we haven't really implemented yet. And also, we plan on, you know, maybe refinding an image. You know, once I put my tracking on it, in case of I don't find it or something like that, we could just, you know, maybe relocate using
sending the centers that, because mine doesn't actually identify any of the centers. It has all possible centers of all vehicles. So he is actually finding the same object. So if we can then pass the centers back to him, then we can do some kind of mean square distance or something and correlate.
Right, I didn't explain that. Actually, the method I'm using here to find the mask on the image is Euclidean distance. Basically, I take the mask and I, you know, subtract it from every point on the image of the smaller image here, and when at the minimum is where the object should be. So that's basically my method of searching for it. And basically, we plan on having the common filter, his center location, and my tracking. We plan on, you know, trying to figure out the best case, which one we would pick out of those three in the case of tracking. So, future work.
Yeah, sure. As of now, like, it being a MATLAB code, it's not particularly efficient. Like, there's just a lot of images still floating around. So in order to actually make it useful, you could probably clean it up more regularly. Like when we did the blurring of the images, it'd be nice to have two or three thresholding levels for distance. So the ones further back, which are already dimmer and have less contrast, you wouldn't blur as much. You'd be, you know, be more forgiving in the back than in the front. Probability masking, like I showed you the mask, that's what I was talking about earlier, to have the more regularly the cars come through, the darker, you know, the higher the number, so it's more likely for when he's predicting. The next thing I really want to work on, though, is eliminating shadows using color and the whole day's worth of pictures to be able to eliminate all shadows from the background image to be able to find the cars better. And the integration of the prediction into the using this paper's method. Thanks, guys.
Any questions?
Mike, go back to your median enhancement. You said you changed it a bit instead of.
Right.
I didn't get it.
Oh, sorry.
What did you change?
Well, what they were doing was just adding at a given interval, say every 3,000 frames, they were adding in. They were adding in a weight. Sorry, we really should have gotten some video, but it's so hard to pull video off MATLAB. Oh great, no, I killed it. Hold on. Get you. Oh, there we go. Come on, man. Sorry. Wait, this
that
is
one, I think the third. Yeah, that. Okay.
From cover slide.
I don't know, man.
What did you do
Look
to
at
it?
this. I don't know.
From cover.
There we go. No.
No.
Sorry. Oh, it's for posterity. I don't know what to do. That's a center.
From current.
Where's from current?
Over the left.
Ah, thank you. Sorry about that. This isn't it either. Okay, what they were doing was just using a single frame, and then say if this weight's 0.1, it's multiplying the whole frame's value by 0.1, this by 0.9, and adding them together to keep it normalized. That was their method of doing it. But I mean, they didn't use this particular weight. But and I found that introduced noise. A few times we'd start to get like cars on the top. When it would stop at the light, you'd start to just get spots showing right up at the light. And then so what Dr. Dimitri suggested that we're putting in is it's going to save 10 images, because I mean they're relatively small, and redo the median over the same way we did it originally, and then introduce that in weighted. So that it'll be more likely to eliminate. That'll be a 10 frame median on top of already a 10 frame median that's a weighted add. So there shouldn't be
your
any.
question is how it takes the median, right? With respect to what?
No.
It's not on the image, it's like across images.
Right.
Yeah, okay.
Right.
So, what's the final goal of this? I mean, you want to track the vehicle, every single vehicle appeared on your video file, or you want to locate the actual geolocation of those vehicles?
Well, we'd like to be able to track them even behind occlusions or whatever, to be able to find them behind trees using like the probability that it's going to be on a road. For
Okay.
example, that if you know, as you can see in the picture, let me find you you know, they have these big trees right here and even over here that you can't even see, and it would be nice to be able to, using his methods and to be able to know that it's about to come out here using that. And that's what the other paper was. It was rule-based methods for prediction, so that you know that it's probably going this way on the road. So we would just like to be able to follow them, you know, follow traffic patterns, maybe count cars, you know, that kind of thing to monitor.
Okay.
Any other questions? All right. Well, thank you.